Okay, so intersection of sets A and B. So that means intersection means and. Okay, the elements that are in both A and B. Okay, so if you look, what is in both A and B? That's going to be your 21s and your 27s there. So you should just have 21 and 27 in there. Okay. The complement of set A, now that means what's not in A. Well, if you look at these numbers, there's like a billion numbers that are not in A, right? So like, what are we supposed to put in here? Well, we have this thing here that identify for us the universal set. So in other words, like for this particular set of problems right here, the universal set, I mean the entire universe here only has these numbers, 20 to 30, okay? The natural numbers from 20 to 30, okay? So these are the only ones we really need to consider as part of the numbers that are not A. So in other words, if A has these, then what's not in A? Well, it's going to be 20. Okay, and then 22, 24, 26, 28, and 30. Okay? And that gives you the complement. All right, now, union, think or. Okay? So what that means is all the elements in A or B. So you're going to do 20, but don't repeat. So write both A and B have 21, so we're going to only write 21 once, then 23, then 24. What's that?
For the first one, why don't you write 21 and 27?
Because those are the only two that are in both A and B. Intersection is what's in A, what is in both A and B. Okay? All right, so 27, and then let's see here. Lost my train of thought. 29 and 30. Okay? Complement of set B. So B has 21, 24, 27, and 30. So that means the complement of B is going to be, well, 20, 22, 23, 25, 26, and then 28 and 29. Okay? The number of elements in set A, easy. There's 5 there. The number of elements in set B, easy. There's 4 there. Define set C so that C is a subset of set A. So a subset of A is just going to be any combination of these numbers that are in set A, okay, and no additional numbers. So, for example, let's just make C be, 21 and 23. Okay, so C is a subset of A. Let's let D be a subset of B. So again, just pick any combination of numbers here that are in B, but don't pick any other numbers, right? Don't add any other numbers in. So let's just do, 21. Okay, what were you going to say, Ava? You said 24? 24 is fine too. Okay? All right. For 9 and 10, this is a way to kind of like show sets, is to use Venn diagrams. You guys probably use these in English class, back in the day, a graphic organizer. So it says create a Venn diagram to represent sets A, B, and U. Okay, so A, all right, we'll just say this one's A right here. We'll say this one's B right there. Okay, so let's see here. A and B, we know they both have 21 and 27. So in the overlapping section here, we're going to put the 21 and the 27 since both A and B have 21 and 27. Okay, but A also has 23, 25, and 29. Okay, and B also has, let's see here, 24 and 30. Okay, so that means what's left for the universal set? Well, let's see, we've got 20, 22, 21, 22, 23, 24, 25. So 26 is in here as well. 27, no. 28 is in here as well. 29 and 30. Okay, we're going to skip 10. Don't worry about 10. I don't feel like describing that stuff. We'll just move on. Okay, you don't have to worry about that. All right. Now we will do some probabilities. Use set notation to write a fraction giving the probability that a number chosen from the universal set will be in set A. Fill in the numbers. Okay, so how many numbers are there in our universal set here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 total numbers in the universal set. And how many are in set A? 1, 2, 3, 4, 5. I know it says use set notation. We're just going to use the fraction there, 5 11ths. Okay. What is the probability that a number in U in the universal set is not in A? Okay. What's the probability that a number U is not in A? Well, again, there's 11 total numbers to pick from there, right, in the universal set. How many are not in A? Well, the complement of set A is 1, 2, 3, 4, 5, 6. There's 6 in there, so 6 out of 11. Okay? What's the probability that the number in U is in A union B? Well, again, we have the union of A and B right here. So there's 1, 2, 3, 4, 5, 6, 7, okay, elements in there out of the total of 11. And then what's the probability that a number in U is not in A or B? Okay, so what are the numbers in U that are not in A or in B? Well, you can see here, there's 1, 2, 3, 4 numbers that are not in A or B, so 4 out of 11. Okay? Questions on any of that? All right, let's turn the paper over here. All right, so then 1, 2, 3 on the back. These all have the same directions for problems 1 through 3. Answer the questions about mutually exclusive or overlapping events. Okay? Are the events choosing a black card and choosing a 10 from a deck of playing cards, are they mutually exclusive? What do you guys say? If you have a deck of playing cards, okay, and you have one event choosing a black card, and you have another one choosing a 10, okay, are those mutually exclusive events? Can you pull both a black card and a 10 simultaneously when you pull one card out? You can. There's like the 10 of spades and the 10 of clubs. Those will both be black. So these are not mutually exclusive. Okay, 10 spades or 10 of clubs. Okay, clubs look like this actually. All right, number 2. If there are 52 cards in a deck with 2 red suits, groups of 13 different cards, and 2 black suits, what is the probability that a card drawn will be black and a 10? Well, we just said, how many black 10s are there in a deck of cards? 2, right? So it's going to be 2 out of that 52, which simplifies to 1 out of 26.
Do we have to simplify it?
You don't have to simplify, no. You can say 2 out of 52 if you want to. All right. Number 3, a can of vegetables with no label has a 1/8 chance of being green beans and a 1/5 chance of being corn. Are the events green beans and corn mutually exclusive? Can your can be both green beans and corn? No. I mean, there are some cans in the grocery store where they mix them up, but in this case, or the vegetables are mixed, right? But no, this one, it's saying there's only going to be green beans or corn. Can't be both. What's the probability that an unlabeled can of vegetables is either green beans or corn? Okay, so that or means we're going to add. So it's just going to be 1/8 plus 1/5. Okay, now these are not, they don't have a common denominator, so I'll change it to a common denominator. That's going to be 5 out of 40 plus 8 out of 40. So we get 13 out of 40 there. All right. Next, Ben spins a spinner with the numbers 1 through 8. For problems 4 through 6, find each probability. Ben spins a multiple of 3 or a multiple of 5. Okay, so for the numbers 1 through 8, what are the multiples of 3, 1 through 8? Okay, yeah, 3 and 6. Okay, what are the multiples of 5 between 1 and 8? 5. So these are, bless you, these are mutually exclusive. There's 3 ways to have this happen, right? A 3, a 6, or a 5. This is an or. So, well, actually, I'll just do it this way. There's 2 out of 6 ways to do it for the A. There's 1 out of 5 ways to do it for B, and 1 out of 6, sorry. So it's 3 out of 6 or 1/2 when you simplify those probabilities there. Okay. Again, these are mutually exclusive. Okay. You can see that there's no overlap here, and so you can just add the two probabilities together. Okay. Question. Oh my gosh, you're right. It's out of 8. Where did I get that from? Sorry. Thank you. So 2 out of 8 plus 1 out of 8, 3/8 then. Thank you. Yes. Okay. 3 out of 8. All right. Number 5, Ben spins a spinner spins a number greater than 2 or an even number. Okay, so for this event, greater than 2, that would be the numbers 3, 4, 5, 6, 7, or 8. And then for the B, it would be an even number, so that would be 2, 4, 6, or 8. Okay, now you can see some overlap here, right? The 6 and the 4 and the 8 are both being counted twice. So the probability of A is 6 out of 8. Probability B, 4 out of 8. And then we'll just subtract overlap. There's 1, 2, 3 overlaps there, so minus 3 out of 8. Okay, they're getting counted twice. And so let's see, that'll be 10 minus 3, so 7 out of 8 is your answer there. Okay. Then spins a prime number or an odd number. Okay, so prime numbers between 1 and 8 are 2, 3, 5, and 7. And the odd numbers between 1 and 8, 1, 3, 5, and 7. Okay? So, for probability of A, there's 4 out of 8. For the probability of B, there's also 4 out of 8. But there's some overlap, right? They both have a 3, they both have 5, they both have 7. So I'm going to subtract 3 out of 8 there for the 3 that repeat. And so we'll have 5/8 when you add those together. Okay? Last but not least here, of the 400 doctors who attended a conference, 240 practiced family medicine. Total, I guess. Okay, 130 were countries outside were from countries outside the United States. Okay, 1/3 of the family medicine practitioners were not from the United States. Okay, well that's easy. We can still calculate that here. So, so if 160 plus this gives 240, we can just subtract here, right? And we have 80. Okay, let's see here. This number plus 130 gives me 400, so this has got to be 270. And then 160 take away 270, that leaves 110 here. And 110 plus 50 gives me 160 there. Okay, so we complete the 2A table. What's the probability that a doctor at the conference practices family medicine or is from the United States? So family medicine would be 240 out of 400 there, plus, or from the United States, 270 out of 400. But that 160 gets counted twice. The 160 gets counted as part of the family medicine and as part is from the U.S., so we'll just subtract 160 out of the 400 there. Okay, and I'm going to calculate this. Okay, so 350 out of 400, which simplifies to, dang it, 7/8. Okay, all right, we're going to run out of time here. So probability the doctor at the conference practices family medicine or is not from the United States. Again, just add the probability, subtract the overlap there. Sorry, I didn't mean to run out of time there. I guess I didn't quite get the video done, but I'll finish it up and we'll get it for you here. Okay.